Hello everyone. In the last video, we learned the basics of matrices, right? Types and operations. So today we'll go on like one step further and learn about the rank of a matrix and echelon forms. So these concepts are basically like very important because they help us solve systems of linear equations easily. So the concept name is rank and echelon form. Okay. So yeah, now rank of a matrix. So what is the rank of matrix? So the rank of a matrix is nothing but the maximum number of linearly independent rows or columns in the matrix. Okay, the maximum number of linearly independent rows or columns in the matrix. Okay, first remember this and I'll clearly explain you further. The maximum number of linearly independent rows or columns in the matrix. Linearly independent, just remember this word. In simple terms, rank basically tells us the strength or information content in a matrix. Okay, the strength or information content in a matrix. Okay, let's see the example. So let's see, this is a matrix. As we know, this is the matrix. So see it, observe it clearly. The second row, this is the second row, this is first row. Okay, the second row is basically an dependent on the first one. Okay, because first row is basically a linear independent row. Okay, how? See, let's write the first row. Okay, linearly independent means it won't depend on any other, so we are directly write this on the top. Okay, now if you multiply 1 with 2, 1 times 2 is 2. Same we have done here, we should done on this side also. 2 times 2, it is 4. Which means if you multiply 2 on the first row, then the result is the second row. So second row is basically depending on the first row. But first row is not depending on anything. So the first row is the linearly independent one. Okay. So the rank of a matrix. Basically the rank represents the linearly independent row or a column is nothing but the rank of a matrix. So here we already got a row which is linearly independent, this one. So how many rows are there? Only this one, right? Only one. So the rank of a matrix is 1. Okay, got it? Okay. Now let's move on to the next one. How to find rank? Basically there are few methods to find rank. We usually have two methods. One method is echelon form, which means basically a row reduction kind of. Other one is determinant, is basically for square matrix. Square matrix, as we know, both rows and columns should be equal, right? So echelon form is the one method to find the rank. Determinant is the other method to find the rank. So in this class, we'll just first learn about the echelon form. Okay. Echelon form. Echelon form. So basically is nothing but a matrix is in row echelon form. Just first write this and I'll explain you. The matrix is in a row echelon form. First thing is all non-zero rows are above 0 rows. All non-zero rows are basically above 0 rows, which means, let's say this, non-zero rows are this, 0 rows are this. Whatever the 0 rows are here, those all should be at the bottom. All the non-zero rows should be on top. Okay. First we have to make the bottom rows as zeros and all the rows at the top should be like non-zeros. Next one. Each leading entry means first non-zero element in a row. Each leading entry is nothing but the first non-zero element in a row. Okay, is to right of the one above it. Okay, each leading entry is to right of the one above it. Every leading entry is nothing but the first non-zero element in a row is to right of the one above it. Okay, I'll explain you about this. Now write the third point. All entries below a leading entry are zeros. Okay, first remember, write these three. First one, all non-zero rows are above 0 rows. Each leading entry is to right of the one above it. All entries below a leading entry are zeros. Okay, now let's move on to the explanation. Yeah, let's take one example. 1 2 3 2 4 6 1 1 1. Okay, let's take this matrix. Okay, first write a matrix. Step 1, this is the step 1. Write the matrix. Our matrix is this, right? 2 4 6 1 1 1. Okay, next step 2. Eliminate below first pivot element, means row 1 column 1. Row 1 column 1 is basically the 1. Okay, eliminate first pivot element, which means basically, just write this one first. Eliminate below first pivot element. Just remember this. R2 is nothing but R2 minus 2R1. R3 is nothing but R3 minus R1. So in our example, R2 is nothing but R2 minus 2R1. 2 minus 2 into 1. This is R1, this is R2, this is R3. 2 minus 1 into 2, 0. R3, 1 minus 1, 0. Okay, so we made these two zeros. So the result matrix is 1 2 3 0 0. Done. Next, this one, the next one. R2 is nothing. Just you should remember these two formulas and then you will get the answer. Next 4 minus 2 times 2. 4 minus 4 is 0, right? Next 1 minus R1 is minus 2, right? Sorry, 2, right? So the result is minus 1. Just write the result as minus 1. Okay. Next 6 minus 2 times 3, which is 6 minus 2 times 3 is 0. Remember, this is not common to every matrix. You should first observe. If you multiply this with the 2, all the elements in the R2 are equal to R1, right? You should observe that logic first, and then we can proceed the next steps, further steps. Okay. First we have to, already what I told you, first you have to observe the first things. If this is this with this is 0, this minus this, R3 minus R1 is 0, then you can proceed with the other things. First, the priority is to make the first row elements should be zeros. Okay. Now this is 0, and this will become 1 minus 3 become minus 2. Okay, got it? Okay, so this is our new matrix. So next step 3. Make pivot in row 3, which means first swap row 2 to row 3. Swapping in the sense 1, 2, 3, 0 minus 1 minus 2, 0, 0, 0. Done? Okay. Now 2 non-zero rows. Now see, there are 2 non-zero rows. What are the non-zero rows? Are nothing but the ranks, right? You can't, this row is not dependent on any other row, right? You can just directly tell from here only, like this one and this one. There is a 2 rows which are not linearly independent, so 2 rows, 2 is the rank in the same way. But just to make it clearly visual and to make it like a to make it like a clear thing, we just make this row, we just swap these 2 rows. So the first row is like 1, the second row rank is 1, so the total row rank of the matrix is 2. Got it? So yeah, this is the way. Now quick check with the determinants. Determinants is the second method, as I told you. So if determinant is basically not equal to 0, the rank is nothing but order of matrix. If in a matrix, if there is no zero rows, then that matrix is nothing but an order, rank is nothing but an order of matrix. If the determinant is equal to 0, the rank is always less than order. Okay. Let's see a small example. Here the determinant is 0, which means you can do R2 is equal to R2 minus 2R1. You can do this, right? So R2 will become 0. 0 here, 0 here. So how many 0 rows? This, right? So how many rows? What is the rank? 1. So 1 is less than, the order is 2 by 2, which is 2, right? The order is 2 by 2, so which is less than, rank is less than order, right? So this is how we do. Okay, now I'll tell you an applications of this rank. Basically to check if a system of equations has a solution. In that way we generally use it. And in computer graphics and engineering problems as well, we will use this one. And one more thing is like to find invertibility of a matrix. Like invertibility in the sense only if rank is equal to order. So we'll do this in the next further classes, just to remember the applications I'm telling. Okay, so the summary of today's class is like rank, which is maximum number of independent rows or columns, and we also learn one method which is echelon form, and the rank which helps in like solving an equations. Okay, so now I'll give you a small homework. Just try doing it. Take this matrix and perform echelon method and guess find the rank. Okay, I hope you will get a good answer. Okay, so yeah, in the next video we'll learn about inverse of a matrix using elementary transformations, which is like another key concept in linear algebra. So yeah, so don't forget to subscribe and practice the homework questions. Okay, yeah, thank you.